Welcome, grade 9s. We'll start the class by discussing our homework. You were asked to convert 27.4 meters cubed into kilometers cubed, centimeters cubed, or millimeters cubed. It may seem intimidating at first, but the procedure is very simple. What you do is first find out what the linear conversion is. You always start conversions by finding out what the linear conversion is, meaning if you had to only measure in one dimension. So if I said, how many meters are there in a kilometer? Most people know there's 1,000 meters in a kilometer, okay? So that's where I start. That's my conversion factor for the conversion of 27.4 meters cubed into kilometers, because that's the first one we're gonna try to do. So there's 1,000 meters in a kilometer, but remember, we're converting units of volume. Units of volume have how many dimensions? 3, right, there's 3. So that's why we're raising the conversion factor to the power of 3, because we're going to do it in length, width, and height. You have to account for every dimension when you convert volume or area, and even linear, there's one dimension, but you're accounting for that one dimension. But you always...
Good morning, everyone. If there are any students that are in Mr. Melnick's math class this morning, please proceed to room 212 immediately. Thank you.
So you always start off by finding out what the conversion factor is for the linear measure, and then apply the appropriate power to convert it. How do we convert it? Since we put this conversion factor to the power of 3, it means we're going to distribute that power of 3 into the bracket. And so we're just going to rewrite the 27.4 meters cubed so we can do the cancellation when it's appropriate. 1 cubed is still going to be 1, but we're going to write it out just so you see how everything is being carried out. Kilometers is going to be cubed. Another way of writing 1,000, as we discussed last week, is to write it as a power of 10. Anything with zeros in it you can rewrite as a power of 10. 1,000 is a 1 with 3 zeros. Or you can say 10 to the power of 3. Because 10 times 10 times 10 gives you 1,000. So I'm just rewriting the number using a power. But because I'm distributing that power into the bracket, I'm going to raise that to the power of 3 as well. So 10 to the 3 raised to the power of 3 is like saying 1,000 to the power of 3. I'm just rewriting it so you can see more clearly what's going on. And then I raised the meters to the power of 3. See, now I've distributed that power of 3 into the bracket. And one of the rules of math is that when you have a whole bracket raised to a power, then everything in that bracket is also raised to that power. So I'm just rewriting it. Then I can cancel my meters cubed. So that disappears. The 1 is still 1, so I don't bother rewriting it because it doesn't change the value of anything. So I just rewrite 27.4 kilometers cubed, because that doesn't cancel. And then the 10 to the 3 to the power of 3 now becomes 10 to the power of 9. So now I've rewritten, I've got my answer already, but I want to simplify it. We know that from the rules of exponents, when you have something in the denominator, what can you do to it? You can put it in a numerator, right? What happens to it when you put it in the numerator? What happens to the power? It goes from being positive to what? Negative. To negative. Okay, so that's what I did here. I brought it upstairs. It turns into 10 to the minus 9. So there's my answer. 27.4 times 10 to the minus 9 kilometers cubed. Is it in scientific notation? No, because you want only one number before the decimal. So I move the decimal over, and it becomes 2.74. But because I made this number 10 times smaller, by going from here to here, I got to make this number 10 times bigger to maintain the same value. So I have my answer, and there it is. When I go from 10 to the minus 9 to 10 to the minus 8, I raised the power by 1, because I jumped by 1 with the decimal. So now there's my answer. You notice I've not used the calculator at all. And actually, when you get good at this, you'll be faster doing this calculation by hand, or in your head really, than you will with a calculator.
Good morning, everyone, and happy Monday. It's Ms. Phillipson, Principal of Father Henry Carr. At this time, I would kindly ask teachers just to stop with any instructions at this moment, just so we can review some important items for the beginning of the week. Thank you. So I would ask for all teachers to please review the schedule for this week with students. There was a communication sent out to parents, so hopefully everyone received that and understands what the week looks like. You are Cohort Eight, and we're happy to have you back. It's been a whole week since we've seen you, and we hope that your online has gone Also, please remember, teachers, to review the expectations for Thursday and Friday with students, as it is a different type of a week as opposed to the first week that we were here. I would also ask all teachers to please review with students the entry-exit points, the exit protocol, washroom protocol, screening, the importance of wearing a mask and correct mask wearing, the importance of physical distancing while in the building, and the importance of hand hygiene. All of those have been added as posters, as attachments to the email that was sent previously. So please ensure that all students understand the expectations while in the building. And many thanks to all of you in Cohort A who remembered that it was your week to come back, that you have come back in full uniform, and we were so pleased to see all of you following all of the protocols, including being at your designated entry and exit point. We thank you so much because all of our safety is in your hands and your safety is in our hands, as we say. So wishing you a wonderful week ahead. I will leave it to the teachers to review all of the protocols while in the building and in your classrooms, and we'll have further announcements at the end of the day. Have a wonderful day, everyone.
Okay. So this is our final answer. And when you get good at using this technique, you'll find that you're faster using this technique than to use a calculator. Because with a calculator, you still have to keep track of your powers. But I'll show you how to do it on a calculator as well. What you would do is say, $27.4 divided 1,000 raised to the power of 3. And you'll get 2.74 times 10 to the minus 8 straight up. But you have to know to enter this step correctly. Otherwise, if you make a mistake, everything after that is wrong. But you have to understand each step, and you have to know your rules of exponents. Let's do number 2, and we'll see how that works. So in the second question, you're asked to convert 27.4 meters cubed into centimeters cubed. The conversion factor for meters to centimeters is 100. There's 100 centimeters in a meter. So, and also you have to decide which one you're going to put on top. How do you decide which one you put on top? What's the criterion? Because I could have put this upside down. I could have put kilometers on the bottom, meters on the top, but it would have given me the wrong answer. What is the criterion that helps you choose which way to put it? Yeah. Which one you want to get rid of? I want to get rid of meters cubed. So that means I have to have meters cubed in the denominator somewhere so that I can cross it out. Okay, same thing here. I got to get rid of meters cubed. So my conversion factor with meters, the meters has to be in the bottom. Okay, and centimeters is 100. The factor is 100 to 1. Okay, so there's 100 centimeters for every 1 meter, but because we're doing a volume conversion, there's 3 dimensions, so we're going to put the power of 3. And then what I did is I looked at 100. What's another way of saying 100 using tens? 10 to the power of 2. That's what I did right there. And then that's raised to the power of 3, so I'm going to have 10 to the power of 2 raised to the power of 3, which turns into 10 to the power of 6, as you see over there. But let's not jump ahead just yet. I've distributed that power of 3 into my conversion factor, so the 100 gets it, the centimeter gets it, the 1 gets it, and the meter gets it, and that's what it looks like. What's 1 to the power of 3? What's 1 raised to any power? 1. It'll stay 1. So this remains 1. Don't have to worry about it. So 27.4 divided by 1 still equals 27.4, so I just wrote 27.4. 10 to the 2 raised to the power of 3 gives you 10 to the 6, because when you raise a power to a power, you multiply the powers. So you get 10 to the 6. Centimeters cubed, because the centimeters cubed doesn't cancel, but the meters cubed does cancel. So now, is this in scientific notation? No. You got to move the decimal over by 1. So it becomes 2.74 times 10 to the power of 7. Because I made this 10 times smaller, I'm going to make this 10 times bigger to compensate so it equals the same number. And there we go. That's 27,400,000. Okay, centimeters cubed. Both of these are correct. The only difference is this is in scientific notation. This one is not. The last one. is to convert meters cubed into millimeters cubed. So again, begin with the linear conversion. Let's put it over here so you can see better. Okay. So the first step is to realize that there's 1,000 millimeters in 1 meter. Then we're going to raise it to the power of 3 because we're doing a volume conversion. And we rewrite the 27.4 because it's going to allow us to, once we distribute the cubed into that conversion factor. So 1,000 cubed, millimeters cubed, 1 cubed, meter cubed, that's what you get here. Another way of saying 1,000 is 10 to the power of 3, but then we're raising it to the power of 3 as well, so that's 10 to the power of 9. The meters cancel, so we don't write them in, and the millimeters don't cancel, so we do write them in. And then to put it into scientific notation, again, the 1 remains 1. 1 to the power of 3 is still 1. I just wrote it there to show you. And then 2.74 times 10 to the power of 10 is what you get as your final answer, because I made this 10 times smaller, so I make this 10 times bigger to keep the equal, to keep the same number, but to write it in scientific notation. Remember, scientific notation, there's one number before the decimal, and the other numbers appear after the decimal. We can add one more sort of bonus calculation to see if you've learned this. I want you to try this. Given that 1 meter equals 10 to the power of 9 nanometers, so nanometers are a billionth of a meter, and there's a billion nanometers in 1 meter. So given that conversion factor, convert 27.4 meters cubed into nanometers cubed. I'll give you 1 minute to do that, and then I'll give you the answer. It shouldn't take you longer than a minute because it's one line of calculation. Fortunately, the one place where we have glare is where it falls right into your field of view. We should find a way to cover that window. Maybe I'll bring in some poster paper and just tape it to that window. Okay. Anybody get an answer yet? Follow the same procedure. The number is going to be really big. You're going to get a really big number as an answer. But it won't look big because you'll be expressing it in scientific notation. Anybody get that?
Yeah.
Good. Good stuff. All right, so let's, if you can master that technique, I'll be very happy with you. because it'll give you capacity to take on calculations that many people would find intimidating. I was going to practice a week, got a little handout. See if you remember what I did last week. They're easy ones. I'll show you how to do the first couple ones. On this sheet, I'll show it to you at home as well. Hopefully it focuses. It's asking you to convert these regular numbers into scientific notation. So, here we go. I'll do the first couple on the board. Take this handout here. You are Enosasu? Oda. Okay, Oda, you gotta go there then. We have to do a seating plan. Or else the boogeyman will get us. Next, this is just review for you, hopefully. Number one on the sheet, it says 625. Remember that when you have a regular number, where's the decimal appearing? Where's the decimal appearing on a regular number? Even though you don't write it. After the last number, right? It's right there. So we want to, in scientific notation, where do we want to put the decimal? What's the rule we use for writing scientific notation? Come on, guys, I did this last week. I repeated it over and over again. Were you listening to me, or did you have headphones on? Come on, somebody remembers. Where do you put the decimal in scientific notation? Between what and what? I hear a whisper, but I don't hear it clearly. The answer is you put one number before the decimal and the rest after. Does that ring a bell? Yeah? Okay. So we're going to move that decimal over twice to get it between the first and the second number. So we're going to write 6.25. Now because we jumped it twice, what are we going to do to the exponent? Remember the rule I said, if it goes this way, the exponent goes up, and if it goes that way, the exponent goes down. So what did we do? We jumped it twice that way, so the exponent goes up. So we did two jumps, so it goes from 0 to 2, so 10 to the power of 2. Okay? Number 2 is 4,216. The decimal place is here. And we're going to jump it over between the 4 and the 2, so it turns into 4.216. Because we jumped 3 times, it becomes times 10 to the power of 3. Okay, one more, and then the rest you can do for homework, because really it's quite easy. And we'll take it up tomorrow. You're at 49,603. Oops.